Hello, math learners. This video is about the ratio test. So we have an infinite series, and our big question is, does this series converge? One thing that we can do is we can look at the ratios of one term and its previous term, and we'll take the absolute value of those terms. Then we'll look at the limit of that ratio as n goes to infinity. If this limit, let's just call it L, if L is less than 1, then our series converges. If our limit is greater than 1, then our series diverges. And if the limit is exactly 1, then the ratio test is inconclusive. So pretty much what this is saying is we're looking at one term and then its previous term. And if this limit of these ratios is growing, then that means that it's diverging. So that kind of makes sense. As if the terms are getting larger and larger as n increases, then of course we're adding up bigger and bigger numbers, and so our sum would diverge. If the things that we're adding on are getting smaller and smaller, then our series will converge. Okay, so that is our ratio test. Let's just look at a quick example. So let's say that we have the example, a sum from n equals 1 to infinity to n over n factorial. So we want to use the ratio test to decide whether this series converges or diverges. So first of all, what is an? Well, an is right there. So an is 2n over n factorial. Now we also need to have an plus 1. So what we're going to do is anywhere we see an n, we'll write n plus 1. So we'll have 2 times n plus 1. And then instead of n factorial, we'll have n plus 1 factorial. Now, what we need to do is find an plus 1 over an and the absolute value. So let's go ahead and copy these things over. So we have, let's write this one as 2n plus 2, and then we have n plus 1 factorial. Okay, so on top we have 2n plus 2, and then we have n plus 1 factorial, and then an is 2n over n factorial. So then that means that 1 over an is equal to n factorial over 2n. So we've got n factorial over 2n. Okay, now what we should do is cancel some things out. So in particular, n plus 1 factorial is equal to n plus 1 times n minus 1 times dot, dot, dot. So in other words, n plus 1 factorial is n plus 1 times n factorial. So we've got n plus 2 over 2n, and then we have n factorial over n plus 1 times n factorial. So our n factorials cancel out, leaving us with n plus 2 over 2n times n plus 1. Okay, so what we need to do now is look at the limit as n goes to infinity of our ratio. And our simplified ratio is n plus 2 over 2n times n plus 1. If we want, we could go ahead and expand out the bottom just to make it more clear. So we've got 2n squared plus 2n. Okay, so when we look at this limit, it has the form infinity over infinity, so we need to use L'Hopital's rule. So we go ahead and use L'Hopital's rule. And that gives us 1 on top, and then the the derivative of the denominator is 4n plus 2. And now as n goes to infinity, we see this goes to 0. Okay, so we have found that the limit as n goes to infinity of our ratios is equal to 0. So let's go back and see what that means. 0 is less than 1. So this means that our series converges. So since this is equal to 0, which is less than 1, we can say that our series to n over n factorial converges, and we know this by the ratio test. All right, so remember, here's our ratio test. Look at the ratio. Take the limit as n goes to infinity. If that limit is less than 1, then our series converges. If the limit is greater than 1, then our series diverges. And if the limit is exactly equal to 1, then our test is inconclusive, and you'll need to use a different sort of test to figure out whether the series converges or diverges.